certain so that all the elements of the array become the same. In one operation, he can take some indices in the array and increase the elements. For example, this he can perform the following. I'm not able to understand the question really well. What's the problem in this? Okay. So maybe I guess this is it. Thank you. Make AP. Three integers a, b, and c can perform the following operations exactly once. Okay, so this is correct. Three positive integers, he can perform the following operations exactly once. Choose a positive integer m and multiply exactly one of the integers by m. Make it so that after performing the operation, the sequence of three numbers forms an arithmetic progression. Not change the order. If there exists a number d, so start this for 1 to n minus 1. For example, this answer t independent cases a, b, and c. So int a comma b comma c, same a b c, and then yes, if you can choose a positive integer m and multiply exactly one of the integers. No, otherwise. Okay, you can choose number m and multiply the second number by 4. Okay, so so maybe let's find the wait, how should I do this? So and d is equals to a plus c, and if d is divisible by 2, and if we divide it by 2 and then it is equal to b, then C out less than yes, and else if d by 2 is actually divisible by b, then also we can say yes. Right. First of all, it can be for any number, right? A, B, and C. So we have to decide. First, decide which two numbers to pick. Right. So should it be only positive dp, or where d is what can be the value of d? Increasing dp or what? It's really confusing. So this number cannot be made an AP, cannot be made into an AP. Why? We can actually multiply this by this number, right? Or two times this number. Can't we? Yes, we can. So this is a yes, this is a no, this is a no. So first test case can so this is obviously wrong, but what primary expression? First test case, the resulting sequence is this. Second test case, resulting sequence can be 32. So it can be a decreasing dp. So decreasing dp is allowed. That's good. Wait, why are they? Okay, so I haven't copied the test cases. So decreasing TP is AP is allowed, and then there is third test case. You can choose m equals to 1 and multiply any number by 1. Okay, so if it's already a DP, then obviously it's a yes. And in fourth test case, you can choose m equals to 9, multiply the first number by 9. Okay. So we gotta see. So we can actually take the difference between 30 and 10 and then make sure if it is divisible by. Okay. But that's not the correct way. There is a lot of if and else statements that I can put, but I don't want to do a lot of if else statements. Should I do all of the if else statements or not? Let's take an array is greater than this is of 3 length, and mhm. So when can it not be converted? When can it be not be converted? In this case, can't we multiply the last number by 0? Okay, so positive integer m. So we can't multiply by 0. When can this not be converted? Hmm. Hmm. How do I figure out this stuff? Like 1, 2 and 2 can be an AP? How is that? Maybe multiply this by 2 and then the AP becomes D equals 0. D can be anything, right? D can be anything. I hope so. Okay. Okay. Let's take the differences between them. So difference 1 would be equals to absolute value of b minus a, and difference 2 would be equals to absolute value of c minus b, and if difference 1 is equals difference 2, then obviously they are an AP. Yes. Else if they are not, then check if we can change one of the numbers to make the difference same. How can we change one of the numbers? Okay. So 1, 6 and 3, what was the answer to this? Man, I don't know how to solve this one. So in this case, what I did was, if we could change multiply b, right? This was for the case where we can change b. So if we can't change b, then if we can change a to be equals to, so it's a plus c by 2 and equals b, so it should be 2b minus yeah, so it should be, wait, I need a notepad, I guess. So 2b minus c, 2 into b minus c percentage a. So if we can change a to be this, then it's okay. And we can just do it this way because it includes that condition that d by 2 is equals b. And else, if we cannot, then just check if we can convert 2 into, let's just make some brackets and just copy this statement and just replace the value of c to a, and this should be c. If we can do this, then also we can say that yes, we can. And if all of this fails, then we see out no. Looks good to me, but can be anything. First of all, is it mandatory to check d percentage to equal 0? And if it is, then we need to check here also, maybe. So yes, 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 no, yes, no, yes, yes, no, no. So last test case is wrong. Why is the last test case wrong? Maybe we can remove this. Now we can check, maybe. Because d should not be divisible by 2 in this case, right? Uh, now it's again a wrong answer. What am I doing wrong? Let's open a whiteboard. What am I missing here? This was useless. So maybe this is the case that negative numbers would fail here. So but there are no negative numbers here. So what my statement is that b is equals to a plus c by 2, right? And in this case, if we can make the middle part to be equals to this, then we are good, right? So we are doing that. So 10 plus 30, that is 40, divided by 2, that is 20. And if we can make the middle part to be 20, that is taken care by this. Multiply something to get that number in the middle part. And if we cannot, then we go into this loop, and it's in this loop states that if we can make a let's take a this is the example of a changing of a. So if we can make a to be equals to 2b minus c, 2b is 2 into 6, that is 12, minus c is 3, that is um, um, 9. And if we can make it a 9, then we say yes, and if we cannot, then we check if we can change the c function. So where is an example of changing of c? I think this should be correct. In my opinion, this is supposed to be correct. So this is failing at this test case, which is 1, 2, 3, 4, 5, 6, 7. Seventh test case. 1, 2, 3, 4, 5, 6, 7th test case. This is failing as this 1, 1, 2. So let's see what this case is. So maybe let's first check for b. So 3 by 2, obviously 3 is not divisible by 2, so this will not be executed. So this will go into this loop, and then we'll check for a, if we can change a in some way. So that will be 2b, that is 2 minus c, that is 0, divide. So if we can change it to 0, so maybe uh, we can change it to 0, right? So why is this? No. Okay, so maybe just make sure that this is not equals to 0, and then we do this. And similarly here also we make sure that this is not equals to 0. So wait, this should not be less than c, right? Let's just test this out first and then try. First of all, are the brackets organized correctly? Okay, so now they seem to be working not fine again. Why are they not fine? So 2 into b, so this was for this, and this is for this, and this for this. Why is this for this? Okay, so maybe another one's required here, and then this is for this, and this for this. Okay, have we made a mistake here also? We did not make a mistake, I guess. So 113 is correct. Is correct, and second last is 211. So 211 would be 3 divided by 2. Again, it will go no, and then it will go for A. Then compilation time exceeded. Why is that? I hate this ID, man. I hate this. I hate this ID. Oh, okay. Now it worked. Yes. No, yes, no, and yes, no, yes. So this seems to work, but I'm not sure about this. To be honest, this should be like to check if that number we are getting is actually less than A or not. But maybe that will be auto checked by that uh, divisibility check. Shit, wrong answer on test 2. So that's demotivating. Let's see how many people have solved this. 5,000 people have solved this. It's almost 6,000. Shit, we are really lacking behind. And I don't know what to do. I mean, this seems all fine, right? This seems perfectly fine. बहुत कहने सारी है, बहुत कहने सारी है. Okay. I can actually say that this should be greater than C. Let me check one thing. So let's just reload this. What happens if we display 5 3 percentage 5? So it comes out to be 3, so it's not actually 0. So this should work, right? Right, this should work. Oh, maybe we did not check here or something. So maybe we have to check that d by 2 is not equals 0. Maybe this and equals to b. Maybe this is the thing we were waiting for. And this should be A, right? This should be A. Imagine if I just failed this because of this. Let's see. Okay, so integer. So this is correct. So our theory was correct. I was a bit shocked at it. And let's move on to the next question. So you are given an array A consisting of n positive integers. You can perform operations on it. In one operation, you can replace any element with A by 2 with the floor, and that is by an integer part of dividing. So if you can apply the operation some number of times, make an array become a permutation of 1 to n, that is so that it contains all numbers exactly once, for example, then the answer is yes. You could do the following: 8 divided by 2 this, 25 divided by 2 12 this, and 6 divided by 2 this, so 1432. So t test yes n Straight line, yes if you can, and no if you cannot. That's a good question. I'm gonna take my previous code. Um, and just paste it in here. Then read this problem, copy the test cases, move this one. So in the second test case it is not possible. Yeah, we can see that. So when is it not possible? When is it not possible? So let's see some more test cases. Okay, so this is possible somehow. This is already a permutation, and this one is not possible. Okay, yeah, it's not possible. Okay, it's not possible. This is also not possible. So anywhere there are two same numbers, it is not possible. No, that cannot be the case always. Like one number, if divisible by 2 twice, can make two different numbers, right? Like we divide it by once and then it yields some number, and we divide by twice, it yields some other number, let's say 8. We can make it a 4 and make it a 2. So duplicate numbers do not indicate a no, in my opinion. So then what is the reason behind the no? 24 divided by 2, 12, 12 divided by 2, 6. Okay, so this is weird. So every number can be brought down to 1, right? So we don't need this, we don't need this, we don't need this. So every number can be made 1, right? So 2, how many numbers can 2 be made? So 2 can be made from 4, 5. 3 cannot make, 6 cannot make, so 4 and 5 can make 2. So if we can ever reach 4 and 5 somehow, then we can reach 2. And let's say 3, and 3 can be made of 6 and 7 and not 8, and so and so. So every number can be made out of the double of that number and double plus 1. So we are gonna take the length. So length is n, obviously, and what do we do? What do we do? What do we do? What do we do? So for int I equals 1, I less than equals n, I plus plus, then what? Maybe sort these numbers, sort a comma a plus n, then what? So since we have sorted it, so essentially larger numbers can make more numbers, right? So 4 can be converted into, so let's not do it here. So 4 can be converted into 2, and then 2 can be converted into 1, right? So 4 can be converted into two numbers, right? Huh, that's weird. So obviously let's start from 0 up till n, and if a of I is less than I plus 1, then we say flag equals false, and we declare a bool flag here, and we break here, and if flag equals false, then we say out no, else we say out yes. Huh. So I'm just doing this greedily, that a particular number at that location can be converted into only that number, but this method is wrong. Why? Let's take an example. So the example is, let's say 1, 2 and 5, and then we go um, then we go like 6, and then we go like uh, then we go like 4, right? So this might seem like we can't do this array according to my method. What is my method? My method is that we sort this first 1, 2, 4, 5 and 6, and then we find out that 1 can be made, 2 can be made, so 3 cannot be made. So this would prove out to be wrong, that 3 can't be made, which is false, right? Because 3 can be made from 6. So 1, 2 and 6 divided by 2 here, and then we do 4 is available readily, and then 5. So how do I tackle that situation? Maybe we can scale down every number to its utmost uh, like decrease every number by divide every number by 2, and then check. Maybe yes, we can do that, but should we do that? So for n I equals 0, I less than n I plus plus, and then what do we do is, if while that a of I is greater than the range we want, then we just divide it by 2, right? Yeah, this should work, right? But this would get us a wrong answer on pretest 2, in my opinion. So this is wrong for even for this test case. Let's see the integers right here. So no, yes, no, and yes. So it is giving a wrong answer on the first test case. That is weird. Wait a minute. I should not sort this. Sort it here. Yes, no, yes. Now the below guys fuck up. So I'm just repeatedly dividing AFI by 2 here, and when it goes below I minus I plus 1, then I just check if that A of I is actually equals to I plus 1. If it is, then we just leave it. Then if it's not, then we turn the flag to be false, and then we just break. So yes, no, yes, no, no, and the last one should be yes. It's wrong. So what's the last? So last one is uh, let's do it by hand. So it is 22, 6 and 4 and 22. 6, 22 and so 22 can be brought down to 11 and then subsequently to 5, so which actually comes under the range. And yep, so we go 6 can be brought down to 3, which comes in the range, and this is again a 5, and this is 4, we leave it as it is, and this when sorted would mean 3 3 4 5 5 5. And as we go on to see that 3 when divided by 2 can be made as 1, right? And 4 when divided by 2 can be made 2. 3 when divided by 2, okay, 5 2 2 2. So this is definitely wrong. So this approach also fails. So now what do we do? This approach has failed. What do we do now? So we cannot make a 4, but we later, and we can make a 2 from 5. That's something. Maybe I need to use the duplicates effectively, I guess, and keep a set, and then just use it as a reference. So maybe take a set and just insert the number into the set. S dot insert. First of all, check if afi if s dot find of afi is not equals to s dot end. I don't remember what does this return. I hopefully that returns the end if it's not found, and if it's found, uh, then we can actually do while s dot find afi is not equals to s, and we keep on dividing afi by 2, and if and we have to make another afi is actually greater than 0, right? And if it is if a of I is equals 0, then we can straight away say that flag is equals to, let's say, flg if flg equals to false, and bool flg equals to, and else s dot insert afi, and yep. Yeah, this should do the job. So when we find 5, 5 is already there. um, does this work? Does this work? Maybe this works. Yes, of course it does. क्या नज़ारे हैं, आगे नज़ारे हैं. Okay, this was correct, I assume. Moving on to problem D, and this had some issues. Um, I need to check them out. Am I not live? What is happening? Am I recording this or not? What is happening? Wait a second. A second. I gotta go.